Hello everyone. It's good to come your way again. This is the Academia series, and we are continuing our series on the light. Please do not forget to subscribe to my channel for more exciting series from me. Please, if you want to comment or you have any addition and omission, or you want a special issue to be addressed for you, that is my email address. You can contact me. You can also go to the comment section under the channel and make that request. I will attend to you. Yeah, we are continuing with our series, and this is going to be the last under the topic light. And at the end of today's lesson, I expect students to be able to explain reflection of light and state at least 2 applications of reflection of light. I also expect them to explain refraction of light and as well state 2 applications at least to illustrate refraction. Now let's start with reflection. Reflection is the bouncing of light rays when it hits a hard surface. That is, when light ray hits hard surface, it bounces back, and that's what we refer to as reflection. Depending on the surface that is reflecting the light, we may have what we call regular reflection or diffuse reflection. Now look at regular reflection. We realize that all the rays coming in were parallel and straight, and after the reflection, they also went away parallel and straight as they came. Now this occurs when we have a smooth and shiny surface. But then when you have a shiny but rough surface, after the reflection, the rays disperses. The rays will be dispersed. And that's what we refer to as diffuse reflection. So take note of that. Now let's look at the laws of reflection. Before we come to that, this is what happens during reflection. We have what we call the incident ray. The ray coming in is the incident ray. We represent this as our mirror. So we have our mirror here. The mirror has got the reflecting surface and then the painted surface. So all the time, the painted surface, we have some lines here to indicate that it's the painted surface. And then the other area with nothing there is the reflecting surface. So when the incident ray coming in, so this is the incident ray coming in, reflects on the mirror and becomes reflected. And then this is an assumed line, which we call the normal, so that you are able to measure the angles of incidence and then the angle of reflection. Please take note, we always measure the angle of incidence from the normal and also the angle of reflection from the normal, not between the mirror surface and then the ray. So take note of that. Now looking at it, the first law states that the angle of incidence is equal to the angle of reflection. So angle of incidence, angle of reflection, they are equal. So if this one is 50 degrees, we expect this to also be 50 degrees all the time. It doesn't change. If the angle of incidence is 10 degrees, we expect here also to be 10 degrees. And that's the first law of reflection. Now let's come to the second law of reflection, which states that the incident ray, so this incident ray, the reflected ray, and the normal, they all lie in the same plane. What do I mean when I say they all lie in the same plane? Let's look at this 3D diagram of a box here. So we have 3 surfaces, surface 1, surface 2, surface 3. We can also say we have three planes for now. So the first plane on top here, this side here is also another plane, and this side here is also another plane. Now, if we assume that this is the surface of the mirror reflecting surface, and we assume that this is the incident ray, and this is the reflected ray, we see that they are all in the same plane. That's if you are here and you are looking at it, you see it to be one line in plane. You don't see the reflected ray going in this direction. So this ray here is not in the same plane as this ray here. So when I say in the same plane, they are in the same line or the same straight line. You don't see the ray going to this side, or you don't see the ray going to this side. That's what I mean by the same plane. It's very important you understand this. Let's look at this once again. The mirror surface, incident ray coming in, reflected ray going there. So if you are here and you are observing from this arrow, you see all this as a line. You don't see any of the rays going there. The reflected ray going here, the reflected ray going there. So that's what I mean by in the same plane. It's very important you understand this. Now let's look at some applications of reflection. Application of reflection is seen in plane mirrors, periscopes, car headlights, formation of images on water bodies, and more. So let's take some look at the applications of reflection. That's we have reflection by water surface. So you can see the image of this lion here being reflected in this water surface. You can also see a boy also looking at his image in a mirror. This also is an application of reflection. Then let's also look at that. We have periscope, a mirror periscope, which is used in the submarine. This is a picture of a submarine, and there is a scientist or an army man making use of the submarine, of the mirror periscope. They use this to observe whether there's no shape or any object on top of the water before they move up. You know that if, let's say, they want to move up and there's a ship moving here, as they move up, it may cause a big disaster. So this one is used to survey the surface of water and see if there's no object there. So coming here, yes, this is how it looks like. So when it comes out of the water, you're able to turn it and look at 360 degrees around, so that there's nothing there. Let's look at the operation of the periscope. Please, we have two types of periscope. We have the one which is made using a mirror, and then you have the glass periscope. I'll talk about the glass periscope pretty soon. So for now, we are looking at the mirror periscope, so that if there's an object here and you are standing here but you want to view or watch that object, you have rays coming from the object being reflected. This is the mirror. So being reflected to this mirror, another mirror here, and the rays are then reflected into your eyes for you to see. So that's the construction of a mirror periscope. Remember, it is arranged such that it makes an angle of 45 degrees with this part if you want it to work perfectly. Another application is the car headlight. You have all seen the picture of the car headlight. Now this is how it works. We have the bulb in the car sending out light rays. So some of the light rays hit the reflecting surface of the inner mirror, and then it is reflected in this direction as you see. So you see all the rays from the light being reflected, and then they all go in this direction. That's why the car light can give light in to cover certain area, because they have been directed. Okay. Then now let's focus on plane mirrors. Plane mirrors. We have so many types of plane mirrors. We have the ordinary straight plane mirror we use to watch our images in our homes. We have the concave mirror, which we use in car headlights and the rest. We have the convex mirror, also used in car driving mirrors and the rest. Now let's look at this. Please be mindful that I told you this earlier. When you consider a mirror, we have the reflecting surface where you don't see anything there. And then we have the painted surface. That's where you see these lines there. So using this as our mirror, we have the reflecting surface and we have the painted surface or the silver surface. Once again, the inner part here is the reflecting surface, and this is the painted part. And here, for the concave, the inner part is the reflecting surface, outside has been painted. For the convex mirror, we have the inner part, we have this part here painted, and then the outside here being the reflected surface. So if you take a critical look, when the ray is coming in, look at how it is being reflected away. You look at the direction very carefully. Ray coming in, reflected away. So this one is used in car driving mirrors, and this one is used in car headlights. This one, because it sends the rays, it diverts the rays, so it is able to cover a large area. It makes the image bigger, but this one converge, so it makes the image a little bit smaller. And this is our normal plane mirrors. All right, please let's continue. So let's look at the operation of the plane mirror. If this is our candle, that is being represented here as an object. Then let's see how it operates. Image from this candle reflects on this reflecting surface of the mirror, and then the image, the rays are being reflected. Then your eyes, you may be standing here to look at it, but then virtual rays is projected in this manner, and then you are going to see the image of the candle somewhere here. So this is how plane mirrors are able to form images. So these are the real rays being reflected into your eyes, but you tend to see the image somewhere here. The image or the object is rather here, but then you come to see the image here because we call something a virtual image. So the rays that is coming into your eyes extends here and form the image at the back of the mirror. Meanwhile, you go to the back of the mirror and you don't see anything there. Yeah, so we call this the virtual image. I think I talked about it in the second series I presented. So this is the operation of the plane mirror. Now, characteristics of images which are formed by plane mirrors are: the image is virtual. Why did I say it's virtual? Because you may see this image. We can't cast it on the screen. You may go to the back of the mirror, but you won't see any image there. So it means it's a false image, virtual, false image. That's what I mean by virtual image. The image is erect. It means it is straight up. So that you see that here, that is the burning or the top of it. You also see the top of it. It's not inverted. It is erect, straight. It is the same as object. If you look at the image size and the object size, they are also the same. So when you look at yourself in the mirror, you see the size of you in the same manner in the mirror. It doesn't diminish. It's not enlarged. Same as the object size. And then the last one, we say it is laterally inverted. Lateral inversion means your left hand becomes your right, and then your right hand becomes your left. That's the tense. So that's what I mean by laterally inverted. Now let's look at some uses of plane mirror. We use plane mirror in constructing Periscope. I think I've talked about that. We also use it in our dressing mirrors. They are also used in stores, in detectives, especially the one that uses the divergent mirror. It enlarges the images. So when someone is sitting maybe at the corner, he is able to look at the mirror face somewhere because it enlarges the image for you. And they are also used in cars and their vehicle driving mirrors. I've already talked about that. They are also used in microscope and also in cameras. Now, this brings us to the end of this particular session, but then my recording time allows me 15 minutes. So this is what I'm going to do. I'm going to also make the video on reflection and also post it together with this one as well. So as soon as you finish watching this, there will be the second part for this one, which is under reflection. I want you to also go there and watch that to make this lesson complete. Once again, do not forget to contact me if you have any issue to talk about. Thank you for watching.